We are in Unit 3, and this is Notes 3. Today we're still talking about function analysis, and we're going to be sketching graphs. So let's take a look at where we have been so far in this unit. So let's say that this is the graph of f of x. Didn't write that down, but let's say that that's the graph of f of x. So here's f, and so far in this unit we've been talking about we've been defining some terms. We've been talking about what the first derivative is doing and the second derivative is doing. So let's review that real quick. So in this curve, we know that from negative infinity, from x is negative infinity till x is a, maybe right here, from negative infinity to a, we know that the function is increasing. So we use closed boundaries if we're talking about increasing. So on this interval, f is increasing. Okay? And then we have a section where f would be decreasing. So f is decreasing from a to c. So from a to c, again, we include boundaries on increasing and decreasing. F is decreasing there. And then we increase again from C to E, we would be increasing again. And then from E to infinity, F would be decreasing. So, a couple things that are important here. For increasing, decreasing, we do include the boundaries. All right, except of course for infinity. Also, f is what is increasing, or f is decreasing. Not f prime, f. So it's important to say what function is increasing or decreasing. Okay? Don't say it. Never say it. All right? So, increasing, decreasing. We also talked about concavity. So for concavity, let's see, for concavity, the f would be concave down from negative infinity to b, somewhere around here. I'm going to make that point of inflection right at b. So from negative infinity to b, f is concave down. It's concave down because any tangent line would be above the curve. Every tangent line there would be above the curve until you get to this point, and then the tangent line would go through the curve, and then just on the right side of this point, the tangent line would be under the curve. So from B to about D, from B to D, D, F is concave up. Concave up, concave down, and concave down from D to infinity. Okay, so for concavity you do not include the boundaries. The only time you include those boundaries is for increasing and decreasing. Okay, so we talked about that. Let's see, for increasing and decreasing, when f is increasing, that means that f prime is positive, right? When f is decreasing, that means that f prime is negative. So increasing, the derivative would have a positive, or the f would have a positive slope. The tangent line would have a positive slope. And for decreasing, the derivative would be negative because the slope of the curve is negative. Okay? For concavity, we're talking about the second derivative. So when f is concave up, we know that f double prime is positive. The slope of the tangent line slope, the slope is increasing there. And for f being concave down, we know that f double prime is negative. So we talked about all of those things, and we know that a point of inflection, is where f double prime changes sign. Okay, so F has a point of inflection when F double prime changes sign. It's not F double prime that's having a point of inflection. It's F that's having a point of inflection when F double prime changes sign. And then we also talked about maxes and mins. So we've been all over that. So that's in a nutshell where we have been. So today what we're going to be doing, up until now we've been given F, and then we've been asking about increasing, decreasing, max, min, concavity, all of this stuff. So we've been given F. Today we're going to be working backward. So you're going to be given information about F prime, F double prime, and you're going to be asked to give information about F. So today we go backwards. So let's just take a look at something here. So if I said that F prime is positive, if I said F prime was positive, and if I said F double prime was negative on a certain boundary, let's just say on a certain boundary. In fact, let's just start by saying all the time. So F prime is always positive, F double prime is always negative. What would the curve of F have to look like? If F prime was positive, F double prime was negative. Well, for F prime being positive, that would mean that F would have to be going up, right? It would have to be increasing. But if F double prime is negative, then we would have to be concave down. We would have to be concave down for F double prime to be negative. So we have to combine these. If F prime is positive and F double prime is negative, the curve for F would have to be this half, or this part of the concave down frown, right? So F would have to look like that somehow, the entire way. So F would have to have that shape. Okay? So that's the sort of thing we're looking at. So what I always do in this section is I get out your worksheet for it, and we do a few of these problems together. Okay, so let's do that. Here's worksheet 3, and let's just look at number 1. Let's get started on number 1. So it says, first of all, it says to let F be a continuous function with f of 2 equal to -1. That's important because they give us a point on f. Okay? We have a point on f. I'm going to try to sharpen this picture up a little bit. It's still a little bit blurry. Okay, well, anyway, we're going to sketch a possible graph of f given different information. Okay, so if we're sketching a graph of f and they give us a point on f, well, that's a good starting point. So I'm going to begin number 1 by plotting that point. The point is 2, -1. So 2, -1 is right here. So let's re-emphasize this. If they give you a point, you definitely want to start there. So always start here if they give you a point. Okay? If they don't give you a point, then you're on your own for that. All right. So here in this number 1, they tell us that for x less than 2, f prime is positive, but f double prime is negative. So I'm going to combine those. I'm going to get a little highlighter up here. Where's my highlighter? There it is. So for f prime to be positive and f double prime to be negative, I know the slope is positive, but the concavity is negative, so the shape has to be something like that for that piece. Okay? For x equaling 2, the slope is 0. The derivative is 0, so the slope is 0. Well, there's only one thing I can do for that. Slope is 0. So right there at x equals 2, we have a horizontal tangent line. Okay? For x greater than 2, the slope of the tangent line is negative, so we're decreasing. We're decreasing and concave down. Decreasing and concave down has to look like that. So I'm going to combine these on my graph of f. So I know I'm flat right at 2, and then increasing but concave down, decreasing but concave down. So this is a possible graph of f. Not the only graph of f. I could draw another graph of f. I could make it a little bit more gradual. Or I could make it a little bit less gradual. So there are several options, but you need to graph one. We're just graphing a possible graph of f. So one of these. Okay, let us take a look at number 2. So for number 2, getting on my highlighter again, first of all, plot the point, right? Plot the point. So if they give you a point, start there. So 2, -1, we're going to start there. Okay. Now, for x less than 2, f prime is positive, so we are increasing. F double prime is negative, so we are concave down. So increasing and concave down has to look like that part of the frown, right? Okay, right at x equals 2, the slope is 0. There's only one thing we can do there. Slope is 0. Okay? Over here for x is greater than 2, the slope is positive. The slope is positive, so we're increasing. And the concavity is positive. So we're increasing and concave up. Increasing and concave up has to look like that. So let's combine those at our point. So we're flat right at 2, right at x equals 2. We're concave down and increasing, and then we're concave up and increasing. So this would be a possible sketch of f. You don't have to draw little arrows, but do draw your curve through whatever grid is shown. Okay? Don't give me one of these wimpy little things. I need to see the curve going through the grid that is shown. Okay? Now, in these first 2 examples, I haven't even mentioned when we were talking about what the curve must look like, I haven't mentioned these 2 things. Okay? For this one, f double prime was negative, which means we're still concave down. We are still concave down there when the slope is 0. So that makes sense. It is confirmed by the graph that we drew. Okay? Over here, the second derivative was 0, which would lead me to believe if we're continuous and if we're twice differentiable, then this would be a point of inflection. Is it a point of inflection? It is, because concavity changed signs. Okay? All right, so at this point I would have you in class do number 3 on your own, and then we would talk about it. Let's go ahead and take a look at number 4. So if you want to pause and do number 3, go ahead and do it. Okay, what would undefined mean? What would undefined mean? So I would start with my point. X less than 2, f prime is negative, so we're going down, we're decreasing. The concavity is negative, so we're decreasing and concave down. So we're going to look like this. decreasing, concave down. Here, the first derivative is undefined. What would make the first derivative undefined? Maybe a cusp, maybe a discontinuity, or maybe a vertical tangent line. A vertical tangent line. That's the only 3 times that we would get a derivative that's undefined. Now, we were given that f is a continuous function, so it's not a discontinuity. So we're looking at either a cusp or a vertical tangent line, or both. Okay? So take that into consideration when you're sketching that graph. So go ahead and pause, finish that little problem, and then come back. Okay, so let's finish this up. So f prime was positive, so we're increasing. F double prime is positive, so we're concave up. So increasing and concave up has to look like that. So when we're going to go and sketch this curve, I would go concave down and decreasing to that point, and then concave up and increasing after that point. So I made this look a little curvy here, but it should be a cusp. It looks like it's a cusp there, which means the slope from the left does not equal the slope from the right. So that is one such graph. Yours might look a little bit different, but still meet all of the criteria. So now I would have you go and do number 4. Okay, so I'm going to let you finish this on your 4 and 5, but let's take a look at number 6. Here they're giving us the graph, and we want to complete the table. So for this part of the curve, we are increasing and concave up. Increasing and concave up. So f double prime is positive since f is increasing. F double prime is also positive since f is concave up. Right at x is equal to 2, we have a cusp, so the derivative is undefined. If the first derivative is undefined, what can we say about the second derivative? It's going to be undefined. Okay? At x equals 2 on, we are decreasing and concave down. Decreasing, concave down. So f prime is negative since f is decreasing. F double prime is negative since f is concave down. Okay? Alright, let's take a look at page 2 here. See if there's anything here I want to talk about. Alright, so here, let's take a look at number 7. In number 7, we have got this, they give us the graph of f prime. So from now on, you guys, you need to be super careful when they give you a graph. You need to be super careful because it's not always going to be the graph of f. Sometimes it's going to be the graph of f prime. Sometimes it'll be the graph of f double prime. So you have to be super careful. Don't make the assumption that you're looking at the graph of f. Okay? So let's think about this. Since this is the graph of f prime, my red just ran out of ink, so I got a new red. So since this is the graph of f prime, I want to think about this. On the graph, this is f prime. So from x is negative infinity to x is negative 1, f prime is negative here. So right here, I don't know how to say this. Right here, f prime is negative. What does that mean f is doing? If f prime is negative, what's f doing? F is decreasing, right? So f would be decreasing from negative infinity to negative 1. Then on this section, f prime is, the curve is above the x-axis. So the curve f prime is positive there. What does that mean f is doing? That means f is increasing there. And then from this piece, we know f prime is below the x-axis, so f prime is less than 0, negative. Therefore, f has to be decreasing again over here. So in part A, when they say to determine the intervals where f is increasing or f is decreasing, and we have to justify our answers, I'm going to say f is increasing on the intervals. So where is f increasing? F is increasing when f prime is positive. Well, f prime is positive from -1 to 2. So -1 to 2. Include, because we always include for increasing and decreasing. F is increasing on this interval since f prime is greater than 0 on -1 to 2. Okay, we have to justify our answers, so that's the justification. All right, f is decreasing on -infinity to -1 and 2 to infinity. So -infinity to -1, I'm going to include that boundary, and 2 to infinity, since f prime is negative on -infinity to 1 and 2 to infinity. Okay? When they say to justify, you've got to say why. And you may not use the word it anywhere. Okay? Don't use the word it. All right. Part B, determine the intervals where f is concave up or concave down. And again, we have to justify. Okay? So, here's my thought process. F is concave up or down when f double prime is positive or f double prime is negative. How can we get information about f double prime if we're sitting here looking at the graph of f prime? Well, f double prime is the slope of f prime, right? F double prime is the slope of f prime because we take the derivative of f prime to get f double prime. So I'm going to say that. F double prime is the slope of f prime. Okay? Which means f double prime is positive on, okay, where is the slope of f prime positive? Well, the slope of f prime is positive from x is -infinity till x is a half. So on -infinity to 1/2. Which means f is concave up on -infinity to 1/2. Okay, what about concave down? F double prime is negative on 1/2 to infinity. So f is concave down on 1/2 to infinity. Okay? Did we justify the answers? Yes, we did, because we talked about f double prime, what it is, and what's happening during concavity. Notice that nowhere did I use the word it. And notice for concavity, I did not include my boundaries. Okay? All right, part C, we're going to sketch a possible graph of f. Sketch a possible graph of f. Did they anywhere give a point? I always start there. Did they give a point? They did. They gave a point, so that's why I'm definitely going to include that point. So 2, 3, I need to include that point there. Okay? All right. Let's see. One thing I did not mention is what's happening right here. Right here. At x equals -1. They didn't ask me in the problem, usually they do, but at x equals -1, what does f prime do? What did f prime do at x equals -1? F prime went from negative to positive, didn't it? F prime goes negative to positive. What does that mean is happening on f? That means f has a relative min at x equals -1, because f prime went from negative to positive. What about over here at x equals 2? Well, at x equals 2, f prime goes from positive to negative, from above the x-axis to below the x-axis. So at x equals 2, f has a relative max, since f prime went from positive to negative. So I know that somewhere at x equals -1, f is going to have a relative min, and at x equals 2, f is going to have a relative max. So relative max here, relative max here, relative min somewhere over at x is equal to -1. So it doesn't matter where. Who knows where it is? Somewhere at x equals -1, we're going to have a relative min. And you can put it anywhere. Sometimes it gets a little bit awkward if you try to put it too close in height to that relative max. I'm going to put it somewhere like not right on a grid point. So somewhere right there, and that's going to be my relative min. Okay, we also have a point of inflection, because what's happening right here? Right here, concavity, the second derivative changed signs, right? So at x equals 1/2, we have a point of inflection on f. So at x equals 1/2, we're going to have a point of inflection, so I think I'm going to put that about right there. And so I'm going to sketch a graph that meets these conditions. So here I'm concave up, there I'm concave up, and here I want to be concave down. And I want it to be smooth. So that's going to meet all of my conditions. You could also do something like this. You could also do something like that. You could also do something like this. So there are lots of possible curves, but I need to be able to see a relative min, a relative max, and I need to see a possible change in concavity, wherever that would happen on your at x equals 1/2. Okay? All right, I'll let you do number 8. Now let's take a look at the next page. Let's take a look at the next page. Goodness, these pages are stuck together. There we go. All right. Okay, so here they're giving us, you can see, and then they're giving us lots of information, and we're supposed to sketch the graph of f. sketch a possible graph of f. Okay? So, number one, you always look to see if did they give me a point, because if they give me a point, I definitely want to put that on the graph. Okay? Sometimes they won't, but sometimes they do. So I'm going to start there. I'm going to say, okay, let's take a look at number 9. So in number 9, they give us a point. F of 0 is 2, so the point 0, 2 is on the graph. So start there. Okay. Now they just say that f prime is positive. They don't give me an interval when f prime is positive, so I'm assuming that f prime is always positive. So f prime positive means the graph is increasing all the time. F double prime is negative. Again, they don't give me an interval, so I'm assuming that it's always. F double prime is always negative, so the concavity is always down, right? So f is always increasing and f is always concave down, so the entire graph must have that kind of a shape. So we're going to draw that nice and smooth with all the way through the grid and just make it have that kind of a shape. No arrows are necessary. I'm assuming it goes on unless you give me an endpoint. Okay? All right, let's take a look at look at one of these ones with a limit, which several of them have a limit. Let's take a look at number 11. Did they give us a point? Yes, they did. They gave us a point. They gave us the origin. The origin is on my graph. Okay? All right, and here they tell me that f prime is positive, which tells me that the graph is going to be increasing. I don't know if it's increasing concave down or increasing concave up, but I know it's always increasing. And then they tell me that the limit as x goes to infinity of f is 1. Well, they just gave me a horizontal asymptote, because as x goes to infinity, that's a horizontal asymptote. So at x equals 1, at y equals 1. So as x goes to infinity, we have a horizontal asymptote. And then they tell me that as x goes to negative infinity, we have another horizontal asymptote at x equals negative 1. I keep saying x. At y equals negative 1. Sorry. At y equals negative 1, we have another horizontal asymptote. Notice that I didn't draw my horizontal asymptote through the entire grid. Why not? Because this is only, a horizontal asymptote is only true when x is going to positive or negative infinity. That's the only spot that it's true. Lots of things could be happening in between there. But as x goes to positive or negative infinity, the curve is going to be approaching 1 and negative 1. So I don't like to draw my horizontal asymptote all the way through because it's misleading to students and they think you can't cross it, but you can cross it. We're not going to cross it here, but we could in general cross it. Okay? Now, this is going to be key because I need for f to always be increasing. So how can we be approaching negative 1 down here and positive 1 out here and always be increasing? Well, it's not going to be something like this. It's not going to be that, because that would not be always increasing. It's going to have to be something like this. Make sure you do not put a vertical tangent line here. Don't give me something like this, because that would imply a vertical tangent line. That would imply that f prime was not always positive. It would be undefined somewhere. If they said f prime was undefined at x equals 0, then yeah, that would mean a vertical tangent line here. So we would have a more curvy curve right there. Okay? All right. Oh, these are so fun to do. So if you want to pause and do some of these on your own and try, that would be a great thing to do. I do want to take a look at 12 because 12 looks like it's a mess. Let's talk through number 12. Okay, first of all, did they give us a point? Well, holy moly, they gave us 2 points. They gave us f of 0 is 3, so the point 0, 3 is on the graph. And they gave us the point 3, 0, so the point 3, 0 is on the graph. 2 points. That's sweet of them. Okay, now let's see. I don't know, where should we start? Maybe, I don't know, this looks kind of simple, so let's start here. F prime at 0 is 0. F prime at 0 is 0. So at this point, F prime is 0. What does that mean? That means that right there we've got a flat spot. A flat spot. The tangent line is horizontal. The tangent line is horizontal. So I've taken care of that. I like to check mark the things I've taken care of so I don't have to come back to them. Okay? All right. Let's just come up here and look at this piece. So when x is negative, so over here, when x is negative, x prime is positive. So the curve must be increasing all the time when x is negative 1. So we don't know if it's increasing and concave down or increasing and concave up. It kind of makes sense that it might be increasing and concave down because of this horizontalness here, right? But let's see what else they say. So, but we'll keep that in mind. I would like to go and find out the concavity when x is negative. So I'm looking down here at these two. So when x is less than 3, when x is less than 3, which would include when x was less than 0, f double prime is negative. So we are concave down when x is less than 3. So yes, we're concave down and increasing here, but we continue to be concave down on the other side all the way till x equals 3. Okay, so I'll keep that in mind. I'm going to go to this piece. I want to go to the piece where I want to keep on going. So I was x is less than 0, so now I'm going to go over here to 0 to 3. So from 0 to 3, which would also include this little bit here, x prime is negative. So x prime is negative means we're decreasing. We're concave down in that spot, so it means that we're going like that. So decreasing, concave down. So now I've taken care of this whole thing, taken care of that. I'm left with these 2 bits. So for here, for x is greater than 3, x prime is positive, x double prime is positive. So on that section we are concave up and increasing. Concave up and increasing. Okay, I always like to look back and make sure I didn't do anything that would contradict one of my bits of information. This would be a value when x prime would be undefined. So was there anything here that would contradict that? Did they tell me what x prime at 3 was? And they never did. They never did. So it could be undefined. So I think we're good. Okay. On number 13, I would definitely try this on your own before you watch this, but definitely try it on your own first. Okay. Did they give us a point? They sure did. 0, negative 2. 0, negative 2. F prime at x equals 0 is 0. That means the slope right here at x equals 0, the slope is 0. So again, we have this horizontal tangent line. So we're going to have maybe it's a relative min, maybe it's a relative max, or maybe it's a point of inflection. Okay? It's one of those things, but it's a flat horizontal tangent line. Okay? All right, I like to go and do my limits next. Okay? So as x goes to positive or negative infinity, the function is going to 0. So we have positive or negative infinity, we've got a horizontal asymptote. Okay? Took care of that. The limit as x goes to 3 is infinity. They just gave us a vertical asymptote at x equals 3. So at x equals 3, we have a vertical asymptote. Now a vertical asymptote I put through the entire graph because you cannot cross a vertical asymptote. Okay? Not like a horizontal asymptote. You can cross that. Alright, so I took care of that. Now let's take a look at our shapes. So it says that f prime is negative, so f is decreasing. F is decreasing when x is less than 0. So when x is less than 0, and I have to hit here, x is decreasing. So, and I know this is an asymptote, so it couldn't be going like that. It has to be decreasing, but I have to get to a flat spot here. So decreasing, going to a flat spot looks like it's doing something like that. Yeah, it's decreasing, and it becomes flat here. Okay, the next spot would be over here. So f prime is positive. F prime is positive, so we're increasing in this section. So we need to be increasing in this section. What's something that we could do to make it increase? Just like that. So here's where we cross that horizontal asymptote, and that's okay. Perfectly fine to do. The last spot, f prime is negative the rest of the way. So f prime is negative the rest of the way. But we can't forget about this horizontal asymptote out here. So I'm going to draw it like this because that's one way to make it satisfy the conditions. And I drew arrows just because it's habit, but you really don't have to draw arrows. It's assumed that it keeps on going. Okay? So this would satisfy all of my conditions. So that would work. Okay? So try 14 on your own, and then come back to me. Okay? Did they give us a point? No, they did not. No point. Well, that's a shame. Okay. So they talk here about origin symmetry, so we will come back to that, definitely. And they have this limit, so I'm going to do the limit. So it says the limit as x approaches 0 from the right. That's a little teeny tiny plus sign. 0 from the right. As x approaches 0 from the right, the function is going to 2. So 0 from the right, the function is going to 2. So even though they didn't give me a point, I know from the right the function is going here. Maybe it's coming from above, maybe it's coming from below, maybe it's coming sideways, I don't know, but it's going there. Maybe it hits it, I don't know, but I know it's going there. Okay? All right. Let's come up here. When x is positive, f prime is negative. F prime is negative, so we're decreasing. So when x is positive, f prime is negative. Maybe it's concave down, maybe it's concave up, maybe it's straight, but it's decreasing. Also, when x is positive, the second derivative is negative. So we're decreasing and concave down. So this has to look decreasing and concave down. So decreasing and concave down maybe looks something like that. Okay? Now, I've check-marked everything except for the origin symmetry. So what does origin symmetry mean? Well, origin symmetry means that every point xy on the graph also has the point negative x, negative y on the graph. Okay? So it's reflected through the origin. So this value here that we don't know, maybe we touch, maybe we don't. Now I know it also has to be down here because we're reflecting it through the origin. Okay? I happened, and I did not do this intentionally, but I happened to draw this curve right almost through 3, 0. So negative 3, 0 is going to be on my graph as well. And now I can kind of sketch this like that. Now, do I need to fill in these points? Should I fill in the points? No, I should not. Why not? If I fill in these points, we no longer have a function because we cannot meet the vertical line test anymore. So don't fill in these points. Okay? This will work. All right, I left just a couple for you to do here, so you go ahead and do those for your homework. All right? Okay.